Hi, this is the third video on the sketch method, putting it all together. So assume knowledge for this one is that you've already watched the others and you know how to find the general shape and how to find the intercepts. This is now going to be putting it all together. Okay, so we're learning to sketch a function from scratch. We're looking at linear, quadratic, cubic and quartic functions. By the end of this video, hopefully you will know how to lay your work out in a clear and easy to follow way. Make note of the dominant term and basic shape, finding the y-intercept and making a note of that, finding x-intercepts and making notes of that, dealing with double, triple zeros and just x factors, and always check by sketching it on your CAS calculator. So we're going to start with this one, the y equals negative 3x plus 2, the dominant term here, negative 3x. Basic shape then is going to be a negative straight line. The y-intercept, so let x equals 0, means we get y equals 2. And the x-intercepts, if we let y equals 0, we're going to get 0 equals negative 3x plus 2. We could rearrange that to get 3x equals 2, x equals 2/3. We could solve that on your calculator. So advanced solve, 0 equals 3x, negative 3x plus 2, which gives you 2/3. Either way, we end up with enough information to be able to sketch it. It goes through y equals 2, it goes through x equals 2/3. It's a straight line going down like that. You should label your graph, so we've got that, y equals negative 3x plus 2, and it wouldn't hurt just to put that on as well. Okay, so there's our graph. The next one we're going to look at is a quadratic. This one has a dominant term of x squared, meaning it's a positive quadratic which has that shape. The y-intercept, we're going to let x equals 0. That means y equals negative 6. It's going to go through there. For the x-intercept, we're going to let y equals 0, and that's going to give us 0 equals x squared plus x minus 6, which we're going to solve. Now it could be helpful to have that factorized in order to make that easy. You can do that on your calculator if you like. You can see I've done it here. Factorize this, gives us x plus 3, x minus 2. So 0 equals x plus 3, x minus 2 like that. So we can let that be 0 or let that equal 0, meaning that x is either equal to negative 3 or 2. Now we went through this in detail on the last video, so if you're not sure what's happened there, please go back and watch number 2. So we're going to have a crossing here, a crossing point there, and a crossing point over here. Now what this means is when we sketch in our function, it's going to come down like this and up through that point there. That is not going to be the turning point, so you mustn't do this, which kind of forces it there, and just go up like that. It's going to be halfway between those 2 points, which means it should be a little more like that, down and then up. Okay, it's not perfect, but it would look something like that. Again, label your graph. So this is y equals x squared plus x minus 6. And we've got all the points on there we need. Alright, now this one here, you're given a cubic, so the dominant term is 2x cubed. Basic shape then, it's a positive cubic, is going to be like that. Now I would suggest factorising this straight away. So we're going to go interactive transformation factor and put in 2x cubed plus x squared minus 13x plus 6. There you go, and we're going to get x plus 3, x minus 2 and 2x minus 1. Was it x minus 2 or x plus 2? X minus 2. There we go. Okay, so the y-intercept, well, let x equal 0, and that's going to give us 0, 0, 0 plus 6. Y would equal plus 6, so it's going to go through there. The x-intercepts or zeros, we need to solve, well, let y equals 0, and we need to solve 0 equals x plus 3, x minus 2 and 2x minus 1. So this means that x plus 3 equals 0, or x minus 2 equals 0, or 2x minus 1 equals 0. So that's going to give us zeros of, well, x is going to equal -3, 2, or a half. So we'll have -3 here, a half here, and 2 there. And it's going to have that shape there, so it's going to go up, down, and right. And don't, again, squash it so that it comes up there, turns through that point. You have no reason to think that the turning point is there. So you're going to go up, down, and through like that. So it should be a nice smooth curve like that. So we've got a turning point on this side and a turning point in between the two. Now this is probably one where it's worth just checking on your calculator to make sure you've got the right shape. So we're looking for 2x cubed plus, where are we? So we're going to do a new one here. 2x cubed plus x squared minus 13x plus 6. Untick anything else you've got there and we'll sketch that. If we just zoom out on that a little bit and a bit more. Well, if we just go into the view window, let's just try -10 to 10 and yeah, -10 should do there, and we'll go up a little bit further, say to 40. There we go. So we can see that our graph actually is pretty close to that. It's not far off at all. Okay. Now, incidentally, if you want to find out what these values are here, if you want to confirm that on your calculator, you could click in here, go to Analysis, Gsolve, and you'll be able to find the roots are where it crosses the x axis. The y-intercept is where it crosses the y-axis. You can also find minimum and maximum points, which we'll come to later on. So if we have a look at the roots, for example, there you go. You can see there's one at -3, a half, and 2, which we already knew. Okay, one more here. Now, this one, again, I would suggest trying to factorise it first. Your dominant term is going to be -x cubed, which means we know it's going to have that shape if we factorise it. You can see we're going to get -x plus 3, x minus 1, x minus 3. Like that. Y-intercept is going to be, well, let x equals 0, we get y equals -9. It's going to be down there. The zeros, we're letting y equals 0, so you get 0 equals -x plus 3, x minus 1, and x minus 3. Now, incidentally, when you solve this problem, it's no different to solving 0 equals positive x plus 3, x minus 1, x minus 3. Just divide both sides by -1, or multiply both sides by -1. So 0 is also going to equal x plus 3, x minus 1, x minus 3. It just makes no difference there. That's going to give us zeros of x is equal to -3, 1, and +3. So we'll have a -3 there, a 1 there, a +3 there. Basic shape is that. So we're coming down, up, and down. Now, I really wouldn't get away with that in an exam, so we should tidy that up a little bit. Let's make it a little bit neater. That's a little bit better. Okay, a couple more for you to have a look at. Here we've got 4 brackets, which means it's going to be a quartic. Try this one, then check back for the solution in a second. And there we go, that's what that one should look like. Now we'll try another. So note that this one has a repeated factor, which is going to give you a repeated x-intercept or repeated root. So it should bounce off the axis. Try it on your own now. Okay, so this one you end up with y-intercepts of -4 and repeated 0 at -2, and then a single 1 at 1, so it bounces off there at -2. Now I would make that turning point to be on that side, but it's worth checking. If you go to graph, we'll do a new one here. X minus 1, x plus 2, x plus 2. We'll just check and see what that one looks like. Yeah, actually it's pretty close, isn't it? So we might want to just zoom in on that if we can. Yeah, interesting one. So the turning point looks to be actually pretty close to there, but I wonder. Yeah, well, we'd have to solve it and find out. Maybe a little over to the right, in fact. So in this case, it's quite like that. So always worth checking on your calculator to see where the turning points lie. Okay, this one is the last one we'll look at. Okay, so an interesting one this. We have a 000 at 2, at x equals 2, and it also goes through 0, 0 because of this term here, just this single x factor, which means it goes through this point here. So it goes straight down here, and then we get a point of inflection here. So again, that was from that previous video. It means it goes through in and out of that point, but the concavity of the curve changes, so it goes like that. Okay, so I'll just label it and we're done with that one. And there we go. Okay, so just a quick recap. Your working out should always include the dominant term and the basic shape. Working out for finding the y-intercept, so let x equal 0 and then carry on. Working for finding the x-intercepts, let y equal 0, then carry on. Take care with your double and triple zeros. Remember, the doubles are going to bounce off the axis, and the triple zeros means you have a point of inflection going through like that. Just x zeros, that means that it actually goes through the origin, so the y-intercept is 0. And don't force your graphs through minimum and maximum points on the y-axis. Always check by sketching on your CAS calculator, as you saw in that previous example where it wasn't quite where we expected. Okay, that's it.